I told you yesterday that I had my epiphany, so I titled my PowerPoint Plant and Soil are One. So what we're going to do is we're going to talk about how powerful the power of diversity is and how it improves soil function. And then I'm going to show you what the premises I use when I go teach about how to set up mixes. And then we're going to use Jack's place and we're actually going to design a mix. Because one time when we did a talk in Iowa, we knew we did a series of workshops all over Iowa. And I really prefer teaching NRCS employees with farmers right in the same room. Because then I have much more engagement from our NRCS employees and they have more skin in the game. But nobody has more skin in the game and seeing their operation change is the landowner. So when we went and did the soil health workshops, I knew this was going to be a frustration because the first time we did soil health, broke up the paradigm, and then we ran out of time because this really is a 2-day course. Really, to do this right, you need to be in the field, like 2 or 3 days, and go out in the field. Because the best way you can learn this is touch, smell, observe, and I really don't like giving more than 4 or 5 hours of PowerPoint and go to the field. But it's hard to put 200 or 300 people. Once you get group sizes that big, it's really tough to do that. Okay, so we're going to start down this direction. Okay, you guys have seen that the physical, the biological, and chemical. This is how it's usually taught. For a long time it's been taught from that perspective. But I want us to start thinking, if this is done more accurately, the biology is the big ring, then the physical and the chemical. I'm going to explain now, through what we understand through niche construction, it's biology that makes the physical. And if once a physical is there, then you can maintain the proper chemistry. So it's really, that's the direction. We used to treat those all and give them equal footing. Now, that's not the case because now we know that earthworms and all these critters modify the habitat. They modify. They're going to take sandy soil and they're going to make it, you're going to start seeing these darker layers. You're going to start seeing aggregation. You can actually see aggregation in sandy soils. So who does that transformation? The biology. So that's the proper way of looking at it. But people ask me, so okay, how do we get this transformation to begin in our soils? To start changing the water holding capacity. To start changing all of it. Because my buddy and I, Rudy Garcia, he's a great soil chemist. We were talking about it, he said, you know, when we went to school, we took graduate level soil physics, soil chemistry, and they would pound it to us. We couldn't get things to work out because we left the biology out. You'll sit there and you pull your hair out and you're thinking everything is this chemical equation and all this powerful mathematics. You don't have to know that. You don't have to go into that depth. All we have to do is provide that key, boy, this thing's going to shot. It's carbon. Carbon. If we bring carbon, here comes the phosphorus with, here comes the nitrogen with. They're all they're very linked together. So that's what we're saying. Now, soil carbon is the key driver. This is Doctor from Australia. Her name is, I don't remember her name, I'll remember in a little while. But her point is, soil carbon is the key driver for nutritional status of plants, and then for the mineral density in animals and people. Soil carbon is the key driver for soil moisture holding capacity. It is carbon. That's why 3 years ago I came to this conclusion on my own. Because all of us in the soil health cadre, we talk to each other all the time. And it was interesting to see how all this thing was verging together. The soil carbon was the key. We all came to it, it's carbon. So that's why I guys want you to walk, it's all about carbon. Now, I want you to see this picture here. This is the aggregate that we talked about. This is the things I want to see. When I get a shovel full of soil, I want to see all that intact. Every one of those parameters intact. So let me ask you, how many of you do farm visits and go out on the farm and work with landowners? Okay, now, how many of you take a shovel and you dig in that soil? The first thing you should be doing is you take a shovel and find out the status. It's like taking the pulse or the heart rate of that farm. How many of you guys do that? I would say the majority, we don't do that, right? We don't do that. I asked farmers, I said, farmers, how many of you are actually checking your soil on a regular basis with a shovel? They don't. Nobody raises their hand. Maybe there's one, but maybe he's been exposed to us. So here's what I want you to see. Every time you dig one shovelful, I want to see this. This is the key. All these have to be in place. I want to see a drillosphere. A drillosphere, I didn't make these up. I want to tell you right now, I've been accused of making these up. And I did not smoke cover crops when I brought this up. The drillosphere is the sphere where the earthworms bore through. Why is that so critical? We have, through soil ecology, we have discovered in those pores, in that drilling apparatus, when you find these beautiful tunnels, they are laden with powerful bacteria, fecal matter from the earthworms. They have anywhere from 9 to 11 times more phosphorus and nitrogen in them. And they have a great array of organisms in them. So why is that so cool? Well, imagine you're growing corn or soybean, all of a sudden that corn root is going down that, and it's picking up all these picking up these nutrients. It didn't have to expend all that energy because there's already a wormhole. So there's all kinds of synergy going on. So that's what I love about ecology. When you address this issue, now you take care of this, take care of this, you take care of this. It's beautiful. It's absolutely gorgeous. Then the aggregosphere. The aggregosphere is when you start getting the clumping of the particles and put it into space. It's like, if you can imagine, as a kid, we used to do those paper mache type, and you start making that. Well, think about it. The paper mache and that glue is those biotic glues created, those polysaccharides like glomalin, earthworms, the root exudates. All those critters start creating this beautiful habitat. What you see here, I don't know if you realize that, but this is grains of sand. This is what you're going to start seeing when you start putting the covers and the organic matter. You're going to start seeing this fusing of these green particles, and you'll start seeing this humidification, these dark colors. You are creating the nexus, the house. Without that aggregate, there is no, it's hard to get proper exchange of the chemistry or the breathing. I call the aggregosphere the lungs and the circulatory system of the soil. In a heavily tilled soil, you see very little aggregation. So the pore space is all dominated just by spaces. This creates the construct. That's what I want, and you'll see it. In fact, you'll see it in this soil. It looks like cottage cheese. You'll see all this beautiful thing, and that's the aggregosphere. Inside the aggregosphere is the porosphere. And we want that pore. There's where the swimming pool is. That's the circulatory system. That's part where all these beautiful active carbon, food flowing in there. And then you've got the chemistry going on. So all that system has to be good. And they're all connected. And here's the conduit for energy, the rhizosphere. Very critical. So when I dig a shovelful, the detritosphere, by the way, is the residue. That is the area, that's 20% of the soil's energy right there. So if you remove it, if you burn it, if you bale it, you just took 20% of the food source. You don't want that. And then at the detritosphere, what do we have? We have the mesofauna, we have all those little critters breaking down, and then you have these beautiful humates and fluidic acids and all these biotic material just leaking into the soil. So all this is connected, all of it is one. You can't have one without the other. So when I dig a shovelful, I want to see in a square foot of soil, in a cubic foot of soil, I want to see anywhere from 10 to 20 earthworms. You can do your own counts, 10 to 20 earthworms. That's equivalent to 850,000 to 1 million earthworms in an acre. So I've just done a visual assessment. I will see in the aggregosphere, I know you're tilling, you must be tilling a lot. So it's telling me, once you start understanding what's going on, you'll start catching on to these things. So this is what I want to see. And even in sandy soil, it's that first couple of inches is the precious skin. And this detritosphere shelters that soil from that heat. And guess where the microbes are? Up 2 or 3 inches. So that's very critical. Now, all of us are going to talk this. We have been taught this, folks. This is called the Inorganic Base soluble state model. When we left school, it was through mass flow, diffusion, and interception. The nutrients work like first. I guess I walked away. Now they did talk about microbes, but it made it sound like this was happening by itself. I think I walked away thinking this was all happening. Okay, I have the water soil solution. It comes in contact with the mineralogy, and you have ions and cations flowing and interchanging, and there's diffusion going on, and concentration gradients, and then I put my chemical fertilizer in, yes, and then all this is happening. But the problem with that is it's the wrong premise. Because now we've based all our agriculture in that kind of concept. We're losing 40 to 60% of our land is being lost. Dr. Kazan, 2002. Because of this concept, because we use a chemistry-based concept, we leave our ground bare for 4 to 8 months out of the year. Because of this concept, we have decoupled the carbon and nitrogen phosphorus cycle. We replaced it. We do it now, everything. So we've decoupled it. So here is the thing that we're supposed to be. This is the right concept. This is where when I do nutrient management, and I've been arguing, when we do manure or any kind of nutrient, it needs to be approached from an ecologically based nutrient management. It is based on organo-mineral pools. It is mitigated by the plant. This is the correct way of looking at it. Because if you do not approach it from this perspective, guess what we're going to do? We're going to put too much manure on the land, too much chemical fertilizer on the land. And that's why we're having problems. When I do an ecologically based one, I don't want more than 200 pounds of peat on the soil. Period. When there's farm already reaching 200 pounds, guess what? Now you're shutting down mycorrhizae. Mycorrhizae, why do I care about my mycorrhizae? We're finding out once you start having higher levels of phosphorus in the soil, then if you don't, mycorrhizae will not sporulate. Why will they build a relationship with the plant if they're drowning in phosphorus? So why should I care about that? Now you're going to have zinc problems. Now you're going to have problems with phosphorus deficiency. Because you remember, how does the plant pick it up? Remember, the surface plants, roots, only occupy less than 1% of the soil surface. So when I have mycorrhizae now, I increased it 20-fold. They're the ones that are going out and helping, seeking for the nutrients and other trace minerals. But because you put too much phosphorus, now you're going to have problems with other minerals in the soil because you got too much phosphorus. But what do we do in NRCS and other agencies? What we do is we focus solely on the phosphorus index. How much is going to be leaked, how much is going to be eroded, those kind of things. I'm not saying they're not important, but you forgot the most important. How about the soil freeway? Who drives it? Okay? So I look at it from the biological perspective. So it changes everything. This changes the way you approach the way you do business. Again, here's that aggregate, and here, if you take a little scope of that, look at this sand particle. That's another sand particle that's being coated with those organo-mineral complexes. And that's going to be an exchange, so that, which has effect, so remember, all this is a function of temperature, pH, metric potentials, electric conductivity, all this very complex processes are happening, but unless that construct's intact, it's really hard to keep this in balance. It's hard to keep the nutrients to be held. That's why it's so important that we have that biological construct in place. Now, here's the thing that's the driver. Diversity, diversity, diversity. This is why our no-till systems fail. Because we forgot the diversity, we forgot the covers. They are the driver. I don't like to call them cover crops, I like to call them biological primers. Energy transformers. That's what they do. They take solar energy and transform it into organic chemistry. into chemical potential. That chemical potential drives the ecosystem. It drives the soil ecosystem. I showed you this picture yesterday. Now, I told you yesterday that Gabe Brown can grow 62 bushel wheat with no fertility, with less than 16-inch precept. Now, here's the soil food web analysis. This, Mark's taken this before. This is a great soil. I like using this one, but they're a little spendy. They're about $110. So what I do is I look and see if the fungus and bacteria ratio are in balance. They have to be a certain balance. A heavily tilled soil will be heavily bacteria dominant. I don't want it to be heavily dominant bacteria because certain bacteria are not good for managing carbon. Now keep in mind, in 1 gram of soil, you can have 50,000 species of bacteria. Okay? It's like saying we have 50,000 types of races. Totally different. So it's incredibly redundant, but when I look at this, now, when we were doing long-term no-till studies, we were finding out that the university soil samples were telling us, you need more fertilizer. But the corn looked beautiful. It was dark green, and we would still put more fertilizer. And so they were following the soil, we were following the recommendations by university. Keep in mind that the university soil samples were based on old technology and on-till systems. They were not based on the systems I call dynamic equilibrium. Yes?
Ray, would our farmers be better taking tissue samples rather than soil samples?
I would do that, yes. I would do the soil samples and the tissue samples, but I'd be using the Riccani test, I'd be using the Lane's test, and I'd be using the Savita test. Until finally, you would only be doing that for a while until farmers catch on, oh yeah, by eye, you get to a point, you will know. And then you'll just be, like for example, when I do a soil food web analysis, I'm going to use that as a benchmark. I want to know what organisms are present. That one I take another 5 years. I don't have to take that one every year. I want to know if I want it maybe every 3 years, because I want to see if my biology is shifting, because that's what you want. I want it to be a balance between fungus and bacteria. And I want to make sure that these predators are present, and she'll tell you. Now look what happens when we took let's see this one. If this is university sample, that wheat, if I took the university soil sample, this is North Dakota's university soil sample in our NRCS model, it said that the game needed 175 pounds of N and 40 pounds of P. Elaine Ingram's soil food web analysis says, no, we have 200 pounds of N. 200 pounds of N. But we're using the old model, and so what are farmers going to do? They're going to go to the university soil sample. So we're getting shifts. Even the universities coming in. We're beginning to realize the model that we have is erroneous. That's the point. That's why he can grow 62 bushel, no-till, 10 years, diversity, cover crops, non-grazing, no fertilizer. 62 bushel. This year we had a young man from Tennessee. He got 135 bushel wheat. He grazed the cover crop, came in with the cows, no-tilled in, 135 bushel wheat. Pretty awesome. It makes a huge difference. When you bring animals into that component and you start bringing the covers, my goodness, it's a multiplying effect. Okay, now we already saw that. Okay, now, very quickly here, I'm going to show you what the primers, these are the primers. There's a constructive way of priming the soil and a destructive way of priming the soil. Tillage is a destructive way of priming the soil. You do prime the soil. Now, what do I mean by priming? You release nutrients. It's like you have a pump, you remember those old pumps that you prime them? You will prime the soil. You will release nutrients when you disc and till the soil. That's because you burn the house down, like I told that rancher, you burn the house down to warm up a hot dog. Turn the grill on. Disking and tillage is not the way to prime the soil. You see those precious aggregates you were telling? You destroy all that. You destroy it. You diminish it. So, tillage. Now, chemical fertilizer. I have it on the destructive way. if it's not used properly. Watch your salt index. I tell my farmers the best way to use chemical fertilizer is very small amounts, and I don't like to see more than 80 pounds of chemical fertilizer at any time, and preferably 40 to 50 units at a time. Give it in small doses. It is a salt. We're seeing that it really screws up that balance. So when you throw it, remember, nature wants to seek balance. Now think about this. You have this elegant universe, and it's working a certain way, and it's mediated because the plants communicate to the microbes, ladies and gentlemen. Yes, they talk to each other biochemically. They're saying, I'm here, let's build this relationship. So you come with this heavy flush of fertilizer, salts, you mess up that whole universe. You have to be careful with it. I prefer, now some companies are now starting to coat their fertilizers with carbon. Very cool. So, fallow, I call that leaky system fire. Uh-oh. Now I get our biologists all in uproar when I bring up fire. Fire is the exception, not the rule. Fire is the exception, not the rule. Didn't say you couldn't use fire, did I? I said be careful with it with cool fires. Because what you're going to do is you're going to burn off a lot of carbon, you're going to emit it out, and then you can ameliorate that soil. You have this coating. You get so hot. You burn off the organic matter. You did impact the biology. Do not think you did not impact the biology. You did. But people say to me, but Ray, I get a green up. Yes, you burned the house down, and it's going to release nutrients. Of course, you've got a response. Careful with fire. Now, the constructive side, priming the soil. My first thing that I want to prime the soil with is exudants. Root exudants. If I have them, then the other thing that happens right away is the bacteria start coming, and then predation comes. The protozoa and the nematodes eat the bugs. The bacteria, they release nutrients. Then manures and compost are awesome. All of them, and then the crop litter. I want to prime my soil this way. That's my priming. Those are my tools for priming. Can we think of anything else in that category that I forgot? How we can prime our soil? Anybody? Is it too early in the morning? I can see you guys are going, You're lucky you don't have an name tag. I'm going to call it on you anyway. I do that. Okay, now, here's what we want. I want you to notice, this is the concept, this is what's being promoted still in parts of our country. It's called wheat fallow. Wheat fallow. No, nothing. They want to save water. What is wrong with that? Look at the carbon in that system. Look at, when I went to go speak to some of the researchers in ARS, they told me, John, we can't, they told me, they said, Ray, we can't build carbon in this type of system. I wonder why. Of course you can't. The prairie was covered 24/7. It was covered all the time. It wasn't just covered in the summer. It was covered all the time. So you're saying, I'm going to put wheat and then leave it bare for 3 months? Okay, and I'm going to say, okay, what I'm going to do to you is, I'm going to feed you for 3 months, and I'm going to, and the rest of the month, you're not going to eat. How would you survive? What's the problem with this problem? Young lady, what's the problem with that? Megan, what's wrong with that? Is that going to work? Continuous wheat? What's wrong with continuous monocultures? Yeah, it's not diverse. And what's going to be the offshoots of that problem? Disease are going to kick your hiney. I had a wheat farmer in Idaho who says, Ray, we can only grow wheat because with the water. No, that's not true. I said, then okay, if you want to just grow wheat, then here's your reward. Diseases kick in their hiney. Rotate. Diversity. Is that better? Getting better, right? How about that? Pauline, what's lacking in that picture? What's lacking in that picture now?
Livestock.
Livestock. The moment you put animals and you have that, oh baby, we're going now. Now you're bringing all of it together. Can you imagine now we have We have the technology with no-till drill, plus we have the mixes, plus we have the cows. Beautiful. Now you've got that soil cycling, and it's going to do well. But what else I love, you know what that is? A picture of the prairie. Guess what? We just mimicked the architecture of the prairie. I care about the architecture on the top. All are going to capture energy different. They have different heights, capturing energy. They have created a micro niche in the top. And guess what else you did? Every root has a different exudate now, leaking different exudates in the system, contributing, getting excited. They have these mycorrhizal highways collaborating. That's why prairies can tolerate the extremes. We created facilitation, complementary, synergies. You see how cool this is going? Forest looks the same way. Do we have any foresters in here? No foresters. Okay, let me give you an example. 1,200 acres, no-till 1972. Typical yields were 150 bushels, soybeans 50 bushels. This is what Dave's branch used to be in 72. You know what his yields are now? 235, 250, and above. We're less than 50 units a day. Now, look at some of the mixes. We've been doing this for 3 years now. Remember, we learned to do these mixes from Dr. Adamir Kalahari. And Dave Brands and I were doing a talk together, John, and I tell you, this is the first time. Dave used to do two-way mixes for years, 30 years. I said, Dave, why don't we go 5, 6, 7? And in front of a whole large group, Dave says, it won't work here. It only works in North Dakota. Well, Dave Brandt has changed his mind. Look at the biomass in one of these plots. The 8-way mix produced 7.4 tons per acre. This particular mix tube produced 5.9 tons. This one produced 5.3 tons and 4.7. It was interesting on the mix number 1, there was no weeds. We did the mix, and then we no-tilled right into that mix. Look at the way some of those mixes look. Look what they did within less than a year. This is data from Ohio. This is an Ohio State doing. Dr. Rafiq Islam did this data. Look at the percent total organic carbon going up. Now, the no-till control plot, look at that. This mix didn't do as well, but look at here. Mix number 2, 3, and 4. Look what happened. How quickly that changed. Look at the total nitrogen. Look at the active carbon, the one I really look at. Look at the food. The check strip, this is 5-year no-till. All of them are the same, 5-year no-till. But look how quickly some of those numbers changed. Total porosity. Remember the red is the check. Look at the difference. His compaction. Some people say, well, what's the best way to get rid of compaction? Biology. Let the biology do it. You don't have to put diesel on it. You just got to be patient. Because tillage does not fix compaction. It's just going to make it worse. Say it again. Tillage does not fix compaction. It's the covers that are going to change it. Look at the difference here on open field. Look at oilseed radish. Look at the penetration resistance and look at the soil depth, and look how they've changed the soils. That's the way we're going to change it. Remember, it's the biology that modifies the physical and the chemistry. Some of those roots are coming down at 1,400 psi, ladies and gentlemen. 1,400 psi. Okay, and this is the conclusion of our study so far. Cover crops had a positive, Rafiq's statements were had a positive impact on soil health. The impact was greater in continuous no-till than conventional. Both chemical and physical properties of soil were sensitive to cover crop management practices. When switching to no-till, it's important to start with a cover crop for better success to maintain economic crop yield. Soil health improves quickly. Okay, there's where we want to go. We want to build that aggregate. We want to see those fungal hyphae. Okay, let's put it here. Now, I do got my little video. The moment you throw that seed, the moment you put it in there, even the bacteria start doing that association with that seed, even when the moment you throw it there. Then the plant starts sending these beautiful chemical messengers. It is communicating to the microbes and saying, microbes, I'm here. Then, and this whole process, now watch this little part of the video, which is really interesting. I want to show you, this is where all the activity, right here. Look at the film of sugar, the root cap. All this is that film. This is coming down, according to Dr. Robert Pinto. I want to write that, lead down that book called, it's called Robert Pinto, his book title is The Second Ahead here. So, this is where all the activity is happening, called the rhizoplane, the rhizosphere. Look at all those organisms starting to graze on that. This is where we want to bring it to ourselves. Look at the protozoa grazing on the bacteria. That's what we want. And you can only do it if you plant it. They will give up, according to this research, it says they can give up all the way up to 70% of the right carbon comes from the root system. We're finding out that is the largest pool of carbon, more than the detritus field, coming from the root. Why do I care about this? Because I wanted to leak this, ladies and gentlemen. I want leakage of amino acids, organic acids, sugars, vitamins, oh yeah, purines, nucleosides, enzymes, inorganic ions. I have never thought that the B concentrations and B12 concentrations get increased the moment you put manure on the land and the microbes together. What the microbes do to the manure. Let me make that again. It is what the microbes do with the manure that increases the concentration of vitamins and nutrients into the plant. And the plants suck them up. Then if we have a good soil food web intact, we have a healthy plant. If we have a healthy plant, we have a healthy animal. We have a healthy animal, we have healthy humans. We're saying when you break that association, we're not picking up all the photo-dense nutrient because the soil food web is not intact. There's the book that I want you to get. That's a spendy book. It's about $200. It's called The Rhizosphere. Now that book is exciting reading, Bob. It all talks about all the potential exudates. We've identified maybe 100, 150 of them so far. It is not a soft read book, but I love that book because it's teaching us, see, we want to get to a point that we're going to do rhizoengineering. Did you know that scientists can use certain plants to degrade toxins like PCB? By putting the right type of plant, you wake up the right microbes that use the toxin as a co-metabolite and eat it. We want to take it to that level where we can take and use the right type of cover crops to get what we want. You see where we're going with this? Cool stuff. This is fresh right off the press. I thought that was excellent. These are quantum dots. What they do is they use special isotopes, nuclear radioisotopes, and they followed it up, and they found out that these hyphae are sucking up amino acids through the hyphae. They're taking up, and those hyphae, amino acids have a nitrogen in them. Plants are taking up organic forms of nitrogen. What did I say yesterday in my class? If most of the nitrogen in prairies and forests is in the organic form, why are they not nitrogen deficient? Remember what they told us in college. What are the two forms of nitrogen in the soil, and how is nitrogen taken up in the soil? What are the two major forms, Kelly, that plants take up nitrogen? Guys, remember?
Nitrate.
Nitrate, and what else?
Nitrate. Nitrite.
Nitrate and ammonium.
Yeah, that was my
Remember? They drilled out in our head nitrogen, ammonium, nitrogen, ammonium. I'm saying to you, also take up organic nitrogen. Now think about it. Forests and prairies, their nitrogen is in the organic form. 95%. Why aren't they nitrogen deficient? Because of this. They can take up amino acids. They can take up organic forms of nitrogen that we were never told. They never talked about this. Now we proved it. Now in the 30s though, the Russians knew plants could take up through the roots organic molecules. Very nice, right John? I tell John, going, whoa, I should have gone to the other side. Okay, look at this. This is a basis that we're showing around. That's what we want. That's what we're going to do. That's what kind of, it's those incredible networks, the internet of the underground. Here's another thing we're getting a benefit out of. This is a spring, this is a field in the spring in North Dakota, no cover crop. Cover crop. You guys see any weeds? In a no cover crop. So, some of these mixes are allelopathic. What do I love about this? I save $15 to $25 an acre now because I designed the right mix. I fed biology, I put the right cover crop mix. Now I don't have to call the co-op and it's going to cost me $20 an acre. Oh, and I hear farmers complain, why I'm paying $30, $40 a cover crop. Really? You're going to complain about that? That's because you don't understand. Once you understand, look at the dynamics I'm feeding soil biology, I'm getting nutrient cycling, I'm getting weed suppression. You tell me that $30, $40 a row crop seed is not going to pay for itself? Once people, like my grazers, there's Dr. Matt Poor, remember I showed you that? Well, how many of you guys went to my grazing talk yesterday? How big did those get, Mark? 12 foot high, huge mixes. All of a sudden I went from half a pound to 2 pounds gain per day. Not a complaint about $50 a cover crop seed cost. Not complaining at all. Here's the soil enzymes I was telling you about. Enzymes are catalysts in the soil. Look what happens when you put no fertilizer, but when you put 80 pounds of fertilizer, look what happens to the soil enzymes. Remember, catalysts is what happens, are the molecules that get soils to cycle, carry out metabolic process. Look what happens when you put peas. Look what happens when you put manure. Look what happens when you have a pasture. See the soil enzymes go up? We want lots of soil enzymes. Okay, look what happens when you burn. This is what I'm telling you about grass, about burning. Enzymes go down. Don't burn it. Vegetable rotation, fescue clothing. That's why I'm saying, some people say, how about bugs in a jug? How about a seed? How about a plant seed? See how powerful the plants are? Okay, here's another demo that would be very good. I usually like to do this demo. How many are educators here? Districts and stuff? Raise your hand. Okay, here's a cool thing. Get a clear bucket or a plastic container. Go get a shovel and get a chunk of sod or a corn plant or anything with all the soil with a big root mass and all the soil intact. And just put it down the bucket and swish it back and forth. And you'll see all these frothy material come up to the top. Those are these biotic glues, the root exudates, all this. And you see in some of the rivers and lakes, you see this white frothy material. Have you seen that in the rivers? That's what it is, are these glues, these biotic glues, these root exudates. That's called the scum. We call it the scum. That's what we want. Look how much alfalfa. Look at switchgrass. Look at the big blue stem. Look at alfalfa. That's why when I have somebody that has a 5-year alfalfa field and I want to start them off in no-till, that's the way to start them, is an old alfalfa field. No yield drag. You why cotton growers, organic cotton growers, tobacco farmers, you know what they'll do? They'll grow and put it in sod for 2 years, it heals the soil, and they come back and till the snot out of it again and put it in tobacco. Because the plant is healing it. Grasses are incredibly powerful for healing soil because they occupy every little square inch. Okay, we saw that yesterday. Move over. Saw that. Look at some of the mixes. Drill. Past this, I'm going to show you here. That is a mix in North Dakota. That mix was 80 acres. We were using the mixes to remediate pastures, to bring them back to life. We used 10-way mixes. How about the economics? People always say, well, Ray, that's all nice, but I have to make a living. How many times do we hear that? I said, yes, you do. So hell, but sure that you'll make a living. This is Dave Brandt's cost sheet analysis. He says this is all his fixed costs. If you look at 1,400 acres, this is his fixed cost. You look all the way, employee benefits, all the way, insurance, everything is $372,000. About 266 per acre. This is a typical no-till after beans. This is, we put what the typical no-till in this country does. I want you to notice all the inputs, all the herbicides, all of it. Those are called the variable costs. So you have $500 to $710 total per acre. Land, rent, everything. If you average 120 bushels, that's going to be $5.92. And the price of corn now is $3.70. Now let's look at Dave's. He's been doing this for 30 years. Look at his costs. Do you see how much less chemical fertilizer and chemical inputs he's using by just using covers? Now look at his cost, $3.50. Cost per acre, $5.01. 2.5 gallons per acre, bushel. Per acre. It's $2.90 here. Now look what happens when you do the mixes. All of a sudden, look at all the variable costs go down. He's making it at $2.36. He's saying now he's got certain fields down to $1.50. Just by bringing diversity into the system. Okay, I want you to look. That is, you know what that is? That is cereal rye. 90 bushels to the acre, and that's in Kentucky. How many of you would plant into that?
Plant into that, hell yeah.
We do. I would. But most people would be scared. You know what we did? Oh, this slide. That is planting soybean right into it. No problem. And we got a 10 bushel increase. Why does soybean do very well in cereal rye? Because not only are you sheltering the soil, keeping the temperatures regulated, but what also you're doing is the cereal rye sucks all the nitrogen out of the soil, and it causes the legumes to nodulate even more. Now, here's how we're going to start doing some mixes. There's the goal. Mimic the range, mimic the forest. We're going to use the diversity as a key. You need to understand, okay, now you need to write this book down. Everybody needs to have this book. You're going to start doing mixes. It's called Managing Cover Crops Profitably. You're going to go to the SARE's website, S-A-R-E. You can get it down free, PDF, or you can pay $20 for it. It's really a good little book because it tells you what the covers do, which ones they do. You're going to want to know if it's going to be broadleaf, it's going to be grass. You want to know if it's cool season, warm season. That is extremely important to understand that. Okay. When I started learning about this stuff, I said, it would be great if I could find some research somewhere to kind of collaborate this, because right now we have about 8-10 years of experience doing this. Because the first thing people are going to start saying, but where's your research? That's the first thing you get all the time. And I said, okay. And so since my goal is to mimic the prairie and the forest, it was fortunate for me, I found Dr. David Tillman's work. I think he's from, I think this was done in Minnesota or Michigan, I'm not sure, what state. But what they did is they had these extensive test plots, and it's been done for 10 years, and it was done on these tall, steep prairies, these tall prairies. And what they did is they would take each plant and find out which one was doing what in that system. Okay? It's pretty, very good paper. In fact, I would recommend reading those two papers. If you've seen David Tillman and biodiversity, I think you can download them, I think you can get them on free. But it's beautiful. You notice with these prairie grasses, if you had 5 to 10 species in species diversity, look at the biomass, how far it went up. The biomass increased. Now look what happens with functional diversity. Functional diversity is broadleaves, lagoons, those kind of things. If we had 3 functional groups in that mix, in that prairie, the biomass went up. So I started using, so I called Jay Fuhrer, probably the most experienced, and Gabe, and I said, okay, Gabe, if I'm in this very dry environment, but I don't want to use much water, how many species would you recommend to put in a mix? Now remember, they never saw this paper. Jay told me 8. I said, wow. They picked that up from experience. So I started putting this, okay, 8 at the minimum. Now look where 8 takes us. So if I have more diversity now in plateaus, and you start having 16, 17 kind of plateaus off, then functional groups. That's why I love to see at the minimum 2 to 3 lagoons in the mix. I do not want to fertilize these things. I want the lagoons to feed the mix. We need to understand we're not harvesting, we are priming the soil. Now if you graze them, that is cool, that's fine, but you're not going to take more than half. And you're going to trample the rest in. The whole purpose is to get the soil cycling and get it healthy and functioning so that you reduce the inputs. Okay. These are some of the rules I tell people. Number 1, do not use covers unless you're going to be a committed student. Don't do it. Because you know what you're going to do? You're going to badmouth cover crops. I prefer you continue doing your own thing. Don't do it if you're going to do it half-heartedly. If you're going to be a student and you're willing to be committed and you're going to be an observer, then this can be a very powerful tool. The other one, be patient. Don't go cold turkey. Take small acreage, work it slowly. And this one, tell your landowners, expect the worst. Your farming expectations is everything. Some of us are walking away thinking that cover crops are the silver bullet. They are not. It is all of it together is the silver bullet. Not one thing is a silver bullet. It is your management, it is your understanding. It is everything you do on that land. It's the manures, it's the compost, it's the animals, it's the way you integrate everything. That's the silver bullet. Not one thing. Cover crops is a tool. Because my concern is that we're going and throwing cover crop seed to throw cover crop seed out there. Then we have crop failures and it spreads. Well, I lost 100 bushel here. I lost 50 bushels here. And farmers we get impatient. You've got to be patient. The soil has been destroyed for a couple 100 years. You want to fix it overnight. So the common question is to me, well, Ray, how long does it take for me to get my soil starting to turn around? If you measure in the macro level, and you measure active carbon, it changes within a growing season. When you start seeing changes in total organic matter, it can take 3 to 5 years. If you care about that. I want to see that active carbon being built right away. Yes, I care about the organic matter. Yes, don't misunderstand me. But that's why when you use the Rick Haney and said, hey, look, remember that cover? You had this much active carbon, labile carbon. Now you have another 100 parts per million. We can use that as a form of encouragement to help the landowner. Don't give up hope. So how do we come in here? We are the cheerleader, encourager, help them. The technical will say, look, you're going the right direction, be patient. Huh? So, remember, our soils are carbon depleted. It takes about 3 to 5 years to start repairing. I used to think it was going to take 10 years to get the soil cycling. But when we start seeing these covers and the manure and all this, we're starting to get cycling a lot quicker. We can repair the water cycle by stopping the tillage very quickly. Within a year or two, you don't have those wet spots anymore. But the nutrient cycle is much more difficult. This is the thing that I feel, John, that I think we need to really focus on. Mentors. We need to have mentorship programs where farmers are mentorship and the DC and your district employees, we have breakfast together and we have soil health meetings. That's what Kansas is doing. Indiana is way ahead of that. A special group of farmers get together and there's an elite group of farmers, you are invited to come. Do not bring just anybody into your group. You want those who have a holistic thought process, have a soil health mindset, that have the same goals you have. And then you share why it's so critical, especially at the more brittle environments like Kansas. If we're going to farm, say we start farming at 20, you got 50 growing seasons. 50 growing seasons. You make a mistake in Kansas, in a brittle environment, it can cost you 10% of your farming career. So if you have people around you that have the same goals and you bring that collective experience together, you can reduce the mistakes. They're too painful. But are you really having the humility, and are you being willing to be critiqued? Because some of these farmers will go and they'll go into each other's place and say, why did you do this? Why did you do that? You want a group that everything, especially